final video for hypothesis testing is done on goodness of fit, or not goodness of fit, excuse me, independence testing. Alright, so today we're going to look at the final one. With independence testing, this is from chapter 11 as well, same as goodness of fit, same chapter. Again, you have your 5 steps. State your null and your alternative. Find your test statistic by using matrices. Again, see calculator steps on how to do that. Pick a method. You can do p-value or critical value here. Compare, and then state your conclusion. When you're doing your null and alternative hypothesis, HO is always that your variables are independent. H1 is that your variables are dependent. For your test statistic, these are your basic steps here, but they're explained in detail more in your calculator steps. But basically, you want to enter your matrix, go to home screen, then you go stat test, chi-square test, and then enter. And it calculates, number one, your p-value. So it's really easy to do p-value method here. And then it also gives you your chi-square test statistic, and then you want to use your table just like we did with goodness of fit. Step 4, compare, and then step 5, state your conclusion. Okay, a couple of bits of information for each of these steps. Alright, number 1, null will always be that your variables are independent. Alternative will always be that your variables are dependent. If you're choosing the p-value, you get the p-value when you do the test statistic in your matrix. If choosing critical value, you need to use the chi-square table, which I've just mentioned. If p-value is less than the significance level, you reject. If p-value is greater, you fail to reject. Alright, when you're using the critical value method, if your test statistic is greater than your critical value, you reject. If it's less than your critical value, you fail to reject. So those are your steps. Again, you can see your notes for more detailed explanation of this. Okay, so let's see an example here. Alright, this example is called open roof or closed roof. So in a recent baseball World Series, the Houston Astros wanted to close the roof on their dome stadium so that fans could make noise and give the team a better advantage at home. However, the Astros were ordered to keep the roof open unless weather conditions justify closing it. But does the closed roof really help the Astros? The table shows the results from the home games during the season leading up to the World Series. Use a 0.05 significance level, alright, there's alpha, to test for independence between winds and whether the roof is closed or open. Does it appear to give an advantage? Alright, so I've got my significance level and my claim. I'm testing for independence. It's clearly stated in the problem, and it will always be stated in the problem. Another good indication that you're doing an independence test is that your data is going to look like it's set up in a table, hence the reason why we're going to use matrices. Okay, so here's my data. Right, first thing we're going to do is all our steps just like normal. Okay, so step 1, HO, H1. Alright, so I'm testing between whether winds and having an open roof or closed roof are independent. So I'm going to say winds and open roof. Actually, we're going to say closed roof because they're saying the closed roof gives an advantage. Alright, winds and closed roof are independent. Okay, or winds and closed roof are dependent. Alright, number 2, I'm going to find my test statistic. Alright, like I said, this time your test statistic is done using matrices. See your calculator sheet, but you should get 0.7982. And you may just want to go through this example to make sure you do get the same results. Okay? Alright, step 3, which also gives me a p-value here too. My p-value that's given on the calculator is 0.3716. So keep that in mind too. Alright, step 3 is I'm going to do my either one of my 2 methods here. In this case, I'll look at, again, restating the p-value, which is 0.3716. Or I can do my critical value, And when I'm talking about critical value, we're going to use our table. Alright, so if I'm looking at my table, this time alpha is 0.05 and degrees of freedom, I believe with independence testing, degrees of freedom are a little bit different. So let me work through this real quick. Okay, I'm going to enter this into my matrix very quickly. Okay, degrees of freedom are also given on your calculator when you do your chi-square test. In my case, degrees of freedom is 1. So before I do this, I need degrees of freedom is 1. Alpha is 0.05. And I'm going to find my critical value. Okay, so I'm going to go to my table, look for degrees of freedom 1. Critical value under 0.05 is 3.8415. 3.8415. Okay, and that's going to be the information I'm going to use to do my comparison. Okay, so step 4, I'm going to do my comparison between the two, and I'm going to look at the two different methods individually. Okay, first of all, if I'm doing p-value, remember we compare our p-value to alpha. Okay, if it's less than, you reject. If it's greater than, you fail to reject. So obviously here I'm going to fail to reject HO. Alright, if I'm looking at my C value, what I'm going to call my critical value, then again I'm going to compare my test statistic to my critical value. And since my critical value is larger, or in other words, my test statistic is smaller, again, same results. You should not have different conclusions if you're using the different methods. Okay, so either way, whatever method you decide to do, most people when doing independence testing will pick the p-value method because they're given the p-value in the calculator and they don't have to do any extra work. The critical value is going to require that you use the table, so it's a little bit tougher to do. Alright, step 5. State our conclusion. Since we're failing to reject the null, again we're saying the null could possibly be true. So I'm going to say, because I want to use my claim, there is not sufficient evidence to warrant the rejection of the claim that winds and a closed roof are independent. Okay, what is that telling us? Okay, there's not sufficient evidence to warrant the rejection of the claim that winds and the closed roof are independent. What does that mean? Alright, well that means it does not appear that a closed roof gives them an advantage, because basically we're saying they're independent of each other, so one doesn't cause the other one to happen. So closed roof gives them no advantage really, based on this particular data, this particular sample of information. Alright, so that's the idea of a independence test. Again, you want to see the calculator steps for calculating your test statistic for both goodness of fit and for the independence test. It will help you tremendously in calculating all of this information.